Here we go. Operations with complex numbers. Powers of I. This is Unit 4, Day 10. Hope you're ready. Last one. This one shouldn't go too far or go too long, but it should be a little bit complicated, a little bit different. It's a little bit weird, especially if you didn't understand imaginary numbers the first time you were taught it. Hopefully this will make more sense for you. Okay, let's review a little bit. We had to introduce imaginary numbers because when we tried to take the square root of -1 or the square root of -4 or the square root of -9, we have problems. So let's take a look, because each of these can be written with a -1. Let's take a look back, and you'll recall that the square root of -1 is I. So that's where we really got this I number. That's why we're using this I number. So now we can deal with square roots of radicals, even though we have non-real solutions, otherwise known as imaginary solutions. Now, when we deal with this I circle, this is I to the, this should be over here somewhere, but this is I to the 1 power. And I to the 1 power is just I. I squared, now, if I is defined as the square root of -1, and I square that, you'll remember that the square and the square root cancel each other. So I squared is just -1. Now, I cubed can be written as I squared times I. Well, isn't I squared just -1? And I is just I. So really this is just negative I. And I to the 4th can be written as I squared times I squared, which is -1 times -1, which is just 1. So when you're dealing with the I circle, if you remember these two, I squared is -1 and I is just I, the opposites are just the negations of it. And that's what we're going to deal with. Simplifying numbers, or simplifying expressions that have imaginary numbers in them. So we'll start with some of the easier stuff. This one. We're just going to add. Adding's easy. 9 plus -6 is 3. -I plus 7I is plus 6I. That's it. Now, I don't ever want to leave an exponent on my i's. I by itself is fine, but as soon as it has an exponent, I know I can convert it to something else. Okay? And that's what we're going to do. Here we're going to get 3 plus 7i minus 8 plus 2i. We distribute the negative. And now we just have to simplify. 3 and -8 make -5. 7i plus 2i makes 9i. You don't change the exponents like adding 7x and 2x. It's just 9x. It's 7i and 2i. It's just 2i, or excuse me, 9i. On number 3, we've got this -4, and we're just going to distribute this negative, so -1, minus I, minus 5, minus 9i. So all I did was get rid of my parentheses, distribute a few negatives, and now I just got to clean things up. 4 minus 1 is -5, minus 5 is -10, and -I and -9i is -10i. That's it. All right, so that's let's take care of the easy stuff. That's just combining like terms, nothing to do there. Now we have to distribute. Now we're going to have to change the exponents on the I, and we're going to have to clean things up a little bit. So 4i times -6 is -24i plus 4 times I squared. It's I times I. But you need to remember, based on what we did already, that I squared is really negative 1. So what I have here is negative 24i minus 4. Because I multiply those, I get minus 4. Normally, it's better to leave it in standard form, and standard form would say put the real number first and the imaginary number second. So your final answer really should be written like this. Negative 4 minus 24i. All right, so we got some double distributing to do on this one, and a little cleanup work. So 2 times negative 4 is negative 8. 2 times 7i is plus 14i. Negative 9i times negative 4 is positive 36i. And negative 9 times positive 7 is negative 63i squared. But I squared is negative 1. So really what I have here is positive 63. All right, so positive 63 and negative 8 get combined to make positive 55. Plus, and then 14 plus 36 is 50. And that's written actually in standard form already. Okay, double distribute here. 3 times 5 is 15. 3 times I is minus 3i. Positive I times 5 is positive 5i. And positive I times negative I is negative I squared. But again, every time you see an I squared, we're going to replace it with negative 1. So this really becomes negative 1, which is really, this whole thing becomes a plus 1. So my final answer is 16 plus, and then combining these two, I get 2i. All right, we're going to distribute. Negative 4 times 9 is negative 36i. And negative 5 times, negative 4i times 5i is negative 20i squared. Now, if you want to think about it and start, all this really does is change the sign, because this is really just multiplying here by negative 1. So it's just going to change this to positive 20. So multiplying by negative, or by I squared, is just changing the sign of whatever you've got. So what I've got now is 20 minus 36i. These are conjugates. Now, if you remember from the last lesson, because these are conjugates, I don't really have to do the insides and the outsides. Now, why do I have this problem here and the same problem down here? That's weird. So I'll do this one up here. 4 plus 2i minus 2i minus I squared. Well, don't these cancel? And isn't this negative 1? So this whole thing just turns out to be a 5. Weird. I don't know why this problem's here, but let's just finish it. We're just adding it up, so that makes 11 minus 6i. And we just did this problem. The answer is 5. So I'm not doing those. All right, now we're going to get into some larger I stuff. I squared times 1 is just I squared. Plus 7 times I cubed. Now I got to clean things up. Isn't this just really negative 1? And I cubed, you'll have to go back to the I circle, but if you remember, it's I squared, I cubed, and I to the 4th. This one was negative 1, so this one is positive 1. This one is just I, so this one is negative I. So I cubed is really just negative I. So my final answer is negative 1 minus 7I. We're going to double distribute. 1 times 3 is 3. 1 times I squared is I squared. And then minus 3I squared plus, minus I to the 4th. Well, I squared is negative 1, so this becomes 3 minus 1. I squared here is negative 1, so this becomes plus 3. And if you remember, I to the 4th is really just 1, so this becomes minus 1. So my answer here is 6 minus 2, which is 4. Now, some of you that are smarter are probably thinking to yourself, there's got to be an easier way to do that one. I'll bet there is. Let's see if we can come up with 4 a slightly easier way. Isn't I squared just negative 1? So really this becomes 1 minus negative 1, or just 2. Now isn't this just negative 1? So this becomes 3 minus 1, which is just 2. GG4. Kind of simple. Alright, I don't know why I'm backing up. I'm going crazy here. 6, and then this is minus 12, so that's negative 6. And then negative I, and this is minus 8, is minus 9. I'm not really sure why that's in there. And I know I don't want to do these just yet. We're going to distribute, so we get negative 36I minus 20I squared. Wait, these are just repeats. Alright, somehow I got repeats. Let's just get to the meat of the stuff. And I think this should have a 12I on it. Otherwise, it's a useless problem. So, just like before, we're not allowed to have imaginary numbers in our radicals in the denominator. We're also not allowed to have imaginary numbers in the denominator. So in this case, the thing I want to get rid of is not the 3. I don't really care about the 3. It's the I that I care about. So I'm going to multiply by I over I. Well, I over I is just 1. So really all I'm doing is multiplying times 1. So in the numerator I get, now these I want to distribute, negative 2I minus 5I squared, because we're distributing this I into both of these. In the denominator I get 3I squared. And again, you can't leave an exponent on an imaginary number. So in the numerator I'm going to get negative 2I plus 5 all over negative 3. Now, the final thing about imaginary numbers is, and they always call this standard form or A plus BI form, we want the real number first and the imaginary number second. And we're going to write it like that. So we're going to rewrite these two over each other. So that's negative 5 over 3. Now this one is going to be over each other, so negative divided by negative is positive, so plus 2 over 3, 2I over 3, excuse me. All right, moving on. We're going to multiply this one by I over I. I think you'll get this stuff. It takes a little while. If you didn't get it the first time, let's play around with this. Let's see if we can mess around with this and see if we can get it better this time. And we'll just keep doing a bunch of different problems with this. All right, we're going to distribute I. So I get I times 4, which is 4I. And then I times 9I is plus 9I squared. And in the denominator, I get 12I squared. So, in the numerator, I get 4 I minus 9. Again, remember, multiplying by I squared is really just changing the sign. All over negative 12. All right, so we're going to rewrite this. So we're going to put this part first, the real part first. Negative 9 over negative 12 is 9 twelfths. And then 4 over negative 12, so that's going to be minus 4i over 12. Now this really should give me a better answer. This is 3/4 minus I over 3. That's the best answer. All right, here we go. We're going to multiply by I over I. So in the numerator, I get 3i minus I squared all over 2i squared. So I get 3i plus 1, because remember, this is minus 1, so that's plus 1, all over negative 2. So my final answer should be negative 1/2, that's this part, minus 3i over 2. Never leave a negative in the denominator, never leave an imaginary number in the denominator, never leave a radical in the denominator. All right, we're going to multiply by I over I. I over I. So I get 5i plus 2i squared. Doesn't that get annoying after a while? Over 4i squared. All right. So it's 5i minus 2, because remember, this is multiplying by negative 1, so that's minus 2, all over 4 times negative 1 is negative 4. So final answer. Negative 2 divided by negative 4, we'll call that 1/2, minus, it's 5i over negative 4, so it's minus 5i over 4. But notice I just put the minus out in the front. Almost done. We're going to multiply by I over I. And we're going to distribute here. So I get I squared minus 2i all over 8i squared. I squared is negative 1 minus 2i all over negative 8. Well, a negative 1 divided by a negative 8 is 1/8. Negative divided by a negative here is positive 1/4, or 1i over 4. We can just put I over 4. Now, just like with the radicals, when I have a binomial, and let me rewrite this so it's larger. I don't know why those are so jammed in there. I'm going to multiply by the conjugate, 1 minus I. Same work, it's just a little bit funkier, minus I. So in the numerator, I get 5 times 1 minus I all over. Now the denominator, again, because they're conjugates, you don't have to do all of the double distributing. I can just do 1 times 1, which is 1, minus I times negative I is negative I squared. Well, negative I squared, isn't that negative times negative 1, which is really a plus 1 here? So my final answer is 5, 1 minus I over 2. Now, I don't like the way that's written because I still want to write it in standard form. So what I really should be doing is distributing and getting 5 minus 5i over 2, which really then should be 5 over 2 minus 5i over 2. That's probably the best way to write this. I wouldn't take off for the other stuff, though. All right, we got a lot of crazy stuff to do here. We're going to multiply by this one's conjugate. 3 plus 2i. 3 plus 2i. So, in the denominator, I don't really have to double distribute because I know that the beginnings are going to give me 9 and the middles and stuff are going to drop out. So negative 2i times positive 2i is negative 4i squared, which is really just a positive 4. But the numerator, we got some double distributing to do. We got craziness to do. So 5 times 3 is 15. Plus 10i plus 6i plus 4i squared. Now this is really just minus 4. So now we can combine. 15 minus 4 is 11 plus 16i. That's putting these two together, all over 13. And to write it the best way, I should have 11 over 13 plus 16i over 13. Again, it's not hugely necessary, but sometimes it is, sometimes it isn't. 8 minus I. 8 minus I. So we'll distribute in the top. We get 56i minus 7i squared. The denominator, again, we're going to be doing beginnings, which is 64, and then it's minus I squared. Well, minus I squared, again, is just plus 1. So my numerator, if I do this correctly, let's see, this is really just a positive 7. So we're going to go 7 plus 56i over 65. Just leave it like that. That's fine. All right, we're getting close. We're going to multiply by 2 plus 3i. 2 plus 3i. I know those other 2 pages, it's saying like, oh my God, I got 2 more pages. But those last 2 pages will take me less than 5 minutes to do all of them. Guaranteed. 2 times 2 is 4. Negative 3i times positive 3i is negative 9i squared. Well, negative 9i squared is really just plus 9. Numerator, I got some more work to do. 7 times 2 is 14. 7 times 3i is plus 21i plus 8i plus 12i squared. Well, plus 12i squared is really minus 12. So I get 14 minus 12, which is 2, plus 29i all over 13. Just leave it like that. That's fine. We're done for that. Last problem of these. All right, the conjugate of 2 plus 7i is 2 minus 7i. 2 minus 7i. So in the denominator, I get 4 minus 49i squared, but that's really plus 49. In the numerator, I got all the work to do in the numerator. I get 10 minus 35i minus 2i plus 7i squared. Well, plus 7i squared is really a minus 7. So in the numerator, I get 3 minus 37i over 53. All right, let's talk about vectors. Let's talk about graphing real numbers. Write the expression as a complex number in standard form. I'm not sure why I wrote that as directions. That's not the directions. I think I was getting tired by the time I got to these. We're just going to graph these. So 1 plus 2i. This is the real part. This is the imaginary part. So you're really just going to plot that point and draw in a vector. So 1 on the real axis, that's here, up 2 on the imaginary axis, so that gives us this point right here, and we're going to draw in the vector. 4i, that's just straight up 4 on the imaginary. There it is right there, 4i. That's hard to see. Negative 5 plus 3i. Negative 5. 1, 2, 3, 4, 5, up 3. 1, 2, 3. So there's negative 3 on the real and negative 5 on the real and positive 3 on the imaginary. And I'm not sure how I'm going to draw this in. And it's a vector, so I draw with arrows. Negative 6. 1, 2, 3, 4, 5, 6, and down 1. All right, it's really hard to draw lines with this thing. Negative 6i. 1, 2, 3, 4, 5, 6. Five minus 5i. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I know you can't even see my... So 5 minus 5i. 5 on the real, minus 5 on the imaginary. Draw in a vector. They have direction and magnitude is what they have. 3i, we're going up 3. Negative 3i, we're going down 3. All right, so on these I said graph each. No, I forgot the word graph. Graph each of the following as conjugate. So what we're going to do is we're going to create its conjugate over here. Its conjugate is just 3 plus 2i. So we'll do the regular in green. We'll do this one in green. 3 minus 2i. There's the original, and I'll do its conjugate in red, 3 plus 2i. So this one's conjugate is negative 4 plus 3i. Notice we're just changing the middle term, not anything else. So if I do the original in green, which is negative 4 minus 3i, and I'll do the conjugate in red, which is negative 4 plus 3i. Notice they're always going to be on top of each other. Finally, 2 more to go on this one. So this one is going to be, the conjugate is negative 2 minus 4i. I'll do that one first. Negative 2 minus 4i. Draw in the vector. I'll come back to this one's conjugate, or do the original, which is negative 2 plus 4i. Over here, I'll do the original, which is 1 minus 4i. That's the original vector, and then the conjugate for this one would be 1 plus 4i, which is up here. And that's really all I expect you to know at this point. Oops, that should be 4i. At this point about imaginary numbers and some operations with imaginary numbers. Okay, hopefully you guys learned something, and that is the end of Unit 4 lessons. I'm going to do a Unit 4, I'll have a Unit 4 practice test, I think, solutions, as well as the actual test that I gave, solutions, posted shortly. Take it easy. Peace out. Oops.